All right, so we're going to take a second to check our worksheet now in order to really check our understanding. Make sure we have vectors down. So this is the finding resultant displacement worksheet. Remember, we're given this key here that shows us what the magnitude of our vectors are as well as the direction. So we always want to use this key, and we always want to use the vectors as the direction they have listed as well as the magnitude. So I'm always drawing A going 3 up every single time. So just a refresher from our last video there. We did do this first one together, so I'm going to skip that one and bring us to this next one. So here it says to draw the path G plus H plus 2F. So I'm going to look to see what G is. So G is 4 to the right. And so I'm going to start my journey off going 4 to the right. H is 3 up. There's H up here. And then F is 2 to the left. So since it's twice of F, I'm going to double that. So 2F, so 4 to the left. So I stop here, distance, entire journey. So 4 plus 3 plus 4, 11. Displacement, I'm 1, 2, 3 boxes away. Draw path A plus 2B plus E plus 2F. So again, I can start anywhere. So I'm just going to start down here. A was 3 up. B was 2 to the right, so I'm going to double that. So 4 to the right. E was 3 down. F was 2 to the left, so I'm going to double that for 4. Distance, add them up, so 14. I returned back to where I started. So if I go back to my starting point, my displacement is 0. So displacement's how far you are from your starting point. So if you've gone back to where you started, you've gone nowhere. Here you're given the same key, and you are asked to make 3 different paths using all 4 vectors, A, B, E, and G. And there's a variety of different answers here, obviously. But what you should find is that your distance and displacement is the same every single time. So what this was supposed to do is to show the commutative property of vectors. So it doesn't matter the order in which I add up my vectors, since all of the vectors going in opposite directions are going to cancel out. I'll end up having the same distance and displacement every single time. Kind of like if I added 5 plus -3 or -3 plus 5. I get the same answer every single time. So again, I'm only using these vectors as they're listed. So if you have something different, you either did not use all 4, or you did something fancy with them. Maybe you did them in a different direction, or you doubled it. So I'm just supposed to use them as they're listed. So maybe I could start off with B here. So B, let's see, that was 2 to the right. So I could draw one going to the right. And then A was 3 up. G was 4 to the right. And then E was 3 down. So if I add them all up, I get 12. My displacement, 6 boxes away. 1, 2, 3, 4, 5, 6. So I could add those up in a different order. I could do G plus B plus A plus E, and I would find 12 and 6, assuming I drew those correctly. 5 now, you're just going to do the calculations without the grid paper. So we're going to assume north and east are the positive directions and south and west are negative. And we'll always assume this unless we're told otherwise. So I'm going, the duck goes 5 east, gust of wind goes 4 east. So same direction, so 5 plus 4 gives me a total of 9 east. Caterpillar goes east first and then west. West is the negative direction. So 4 plus -5 to give me -1 west. Timmy, 30 north, 50 south, 20 north. So north are positive directions, south is negative. So 30 plus -50 plus 20 give me 0. And then John, 24 east, 36 west, 12 east, 6 west, -6.